Oops. Okay. Just recap some important equation. So the first one will be this one, V equal to V0 plus acceleration T. This one, when you only have, you can only use this one when you have a constant acceleration. Eh? Okay, when your acceleration is changing, then you need to be careful, right? Next one will be this one. This one. Okay. S equal to S0 plus V0T plus half AT squared. This one also when you have a constant acceleration. The third one is this one. V squared equal to V0 squared plus 2AC S minus S0. So these three equations, when you are talking about particles or a body that move in straight line. Okay, just take note on your personal note there. These three equations that I mentioned just now is for object that move in a straight path. So how do you know that you can use this equation? When you're given a scenario when they move in a straight path. When you see this keyword in a question, then you know. You can use either three equation that I mentioned to you just now, and even this one. Huh? Okay. We already covered example 1 previously, and also example 2, where there's a bullet go through a water. Today we recap one more example, just to recap the application of the Newton motion equation. All right, let's look at the question and see what we can do with the equation that we learned. So during a test, a rocket travel upwards. Maybe I'll move to this side. Okay. Yeah. So during a test, this rocket over here, it travel upward with a speed of 75 meters per second. And when it is 40 meters in the air, okay, you can see this rocket fly in 75 meters per second. And then at 40 meters in the air, the engine failed. The rocket engine failed. Okay. Let me move outside from the screen. All right. Then what happened? Then so when the engine failed, this rocket still travel at this point. The rocket travel at a speed of 75 meters per second, and I label this point as point A. And what happened to the rocket if the rocket failed? It's going to slow down, right? So from this point onward, the rocket going to slow down. So determine maximum height. We need to know calculate the maximum height of this rocket, because you know that as this rocket to continue to climb, because you still have velocity, continue to climb up and start to slow down until one point it reach velocity 0. You need to find the location, the S, B. There's a point there where the velocity becomes 0. You need to find this S from the origin. Here to here is your SB. So the height of A, label as SA, means location of A, S sub A 40 meter. So it continues to travel but slowly at this point. At point B, velocity at B is 0, where no longer energy given because engine already failed. So you need to find the position of B, which is here to here, B. You need to find using the three three equation that we mentioned just now. And then find the speed. Find the speed just before it hit the ground. Means when the rocket cannot go further, means zero already, what does the rocket will do? It will flip. It will flip direction and heading down. You need to find a speed at this. Okay, so the rocket will turn at zero speed and it start heading down. You need to find a speed at this point, okay, before it hit the ground. So at this point. So you need to find the speed here. You need to find the location of P where the velocity is zero. So this is SB, which is from the ground until point B. And then I label the ground point where the rocket hit the ground C. So location of C and O actually is the same. It's only just as a reference point to tell that this is the point where the rocket going to hit the ground. So you're given extra information here where the motion is subject to a constant downward acceleration, meaning you have a gravity force. No matter how fast it goes, there's always a gravity force that acts downward. And the question asks you to ignore the air resistance for the rocket. This is a simplified question. So if you're simulating or you're calculating for a real rocket launch, you need to consider air resistance. But for this question, we ignore air resistance and we only consider gravity force which is act downward. And before you start, you need to know where is your positive direction. Going up is positive. Going down is negative. And going to the right, in this case, you don't go right, but go straight up and then at this location, it flip and then go down. Okay, so you only have one dimension problem here. So first, know where is positive, where is negative. Before you solve engineering dynamics question, you always know where is your location. So where is positive, where is negative is very important. So next information we are looking for is to find the maximum height in the question, which is how do you determine the SB here? From here to here, how do we find? So the next question you ask yourself is what information we have to help us to solve SB from BO to B, means we measure as SB, okay, the height of SB, where velocity is zero. So you know information that you have, point A, from point A onwards, your velocity is 75. At P equals 0, where we count from the engine failure, and the height is 40 meters here. At maximum height, we're at this location, SB here, at location B, velocity is 0. So by looking at the three equations that we mentioned before we look at example 3, again, at what look, although this question doesn't mention the keyword straight line, but from the photo that you see here, the rocket move in straight line, and then rotate, then go down straight line. Basically, you know you can use the three equations that we mentioned just now. Choose either one of the equation that you can fill in the missing information. You have VB, you have VA, you have the acceleration of gravity, you can find. Okay, there will be one particular equation that already have all the missing parameter, only one you need to find. You have VA, VB, you have constant. Okay, you have constant, the word constant there, constant acceleration means you can use the three equation that we learned just now. And remember, read carefully and then purposely mention downward for you, downward acceleration. We know that all the direction going up is positive, and in the question it mentioned downward means remember. Okay, remember to put negative sign for your acceleration, especially when you deal with gravity. Again, put a special note in your notes, personal note. This is a very popular mistake done by students when it comes to gravity force. Again, this is a very famous area of mistakes that we've seen. Every time in a class, there will be at least one student that will forget that going down is negative. Then if you use positive means you accelerate upward. You become faster and faster and faster. So take note on this. In this case, acceleration going downward. That's why negative. And I put a note here for you also for your revision, because initially we already defined all the location, all the direction going up is positive. That's why we use a negative sign there. So the next question you ask yourself is which equation to use. So from the three equations, you look at the information you have, choose the one that you can fill in or substitute the most information that you can have. Then there will be one missing information with this one. Okay, with this one. Why? Because in this equation, you have the final velocity, you have the initial velocity, you have the constant acceleration. You don't know the last location, but you know your initial position. This speed and this location, this location and this speed is linked together, because at here, at point A, you know at point A the height or the position is 40 meter. Here 40 meter linked to what happened at 40 meter is 75. So your initial velocity here is 75. This one linked to this one. Any questions so far? Any question you don't know? Why should I use this one?
So,
Clear? Okay.
for the time, you assume or
Which one?
the time
No.
t equals 0 second.
Yeah. Okay. Why I put A as my T0? You ask yourself, is there any meaning you start from here? Here to here, what happened to the velocity? Velocity constant, right? From this point to this point to this point, there's a changes of, you can say there's a changes of velocity. Here, velocity 0. At this point, velocity 75. There's a change of acceleration. So when there's a change of acceleration, can you use the three equation just now? The answer is cannot. Because the three Newton motion equation just now, you need constant acceleration to use. So that's why from this point to this point you cannot use. Okay, from this point to this point there's a change of acceleration, and in this point is where the energy loss, the engine fail. So we put as A. From this point onward, there's no more input from the engine, and this from this point onward up to this point onward is because of the gravity. Here to here is because of the downward, the acceleration of the gravity. It changed from 75 to 0. That's why we choose A point rather than 0. Is it clear? Is it clear?
Yes, sir.
Okay, so you need to be careful when you use the 3 Newton equation, Newton motion equation. You need to look at the case. All right. So if you really want to use, also no problem. But you need to analyze from this point to this point. Then you use the data from this point, continue to this point, because it's a different stages of motion. Here to here, there's a change of velocity from even it is in this case, you don't know what is the velocity at here. The question doesn't tell you. You don't know even the even you assume is 0, right? Velocity is 0 at here. Then it reaches from 0 to 75. There is an acceleration happen here. Even there's a gravity force, so you will be confused yourself with acceleration if you start from 0. Okay, so for this question, we mark point A as our starting point. So A to B will help you to solve this question because the question asks you maximum height of B. So you link the information at A as T0, or in this question, you only look at this position and this position. What happened at this point to this point? Because you know the height of this point. You know the height of this point. Okay? So that's why you substitute value at A. You substitute the value of A inside here. Value of VA 75 over here, and SA over here. Acceleration, gravity. This one is the final velocity, you know 0. Now another case, back to the question by one of your friends just now. You can use, you can try to use point 0 to B. But I'm not sure. You can try, but there will be a missing information because you don't know the real velocity here. Okay, you can assume as 0, but it doesn't give you accurate calculation because you don't know the velocity at here. Right? The confirmed information you have is point A information. So try to solve problem with the confirmed information. Okay, so that's why we use point A to point B. So I pull the information a little bit up. I replace the information. I change the general equation. So in the exam test assignment, when you write general equation, there's a point for you, there's a marks for you. So if you use the correct equation, you get a 3 marks, 1 mark there. Just to secure if you substitute the wrong answer later on. Okay, so you just have to use to secure some marks there. So you substitute accordingly. This is the final. Final is at point B. This is initial at point A. This is the gravity force. This is the final B, initial A. The rest is just substitution. VB 0, VA 75. Acceleration, again, this is the popular mistake done by students. They will forget acceleration is going downward. That's why I get negative. Because we already defined going up is positive. So acceleration is going down. Gravity is always pointing down. So remember, don't make these mistakes in your answer. Then SA, we fill in at 40 meter. SB, we need to find. As you can see, study this equation. There's only one missing. There's only one unknown here. Rearrange, use your calculator. Again, press carefully. I've seen some students also, when they answer question in test or exam, they panic. They press the wrong key in the calculator. They give me some a surprising answer at the final answer, right? So the distance at point B will be 327 meter. Okay, from here to here is 327 meter. Okay. Next, we look at velocity. At this point, we already solved the maximum point. Next, we can use the information from here to point C to find, because you already have your SB, you already have your velocity here. You know the acceleration is pointing downward. You only need to find the velocity at C. So from the three equations that we discussed just now, right? You choose the correct one. Again, this equation gives you only one missing parameter. VC you need to find. VB you know, means at this point, the velocity at B you know. Acceleration you know, which is pointing downward. Because from this point onwards, there is no input from the engine. You only going downwards. So point C minus point B. How you know it's point C? Because from the general equation, this one is the final position or final location. S, final location is C, is here. And this in initial B. So if you refer to this diagram, what do you think the value of SC? What do you think?
Maybe 0, sir.
Correct. Okay, so we start substituting number. VB, you know, 0. Again, acceleration is going downward. Continue to use negative because the overall system going up is positive. Huh? Overall system is positive. Going up is positive. So no matter how you change, the gravity always pointing downward. That's why negative sign here. Although the rocket is going downwards. Don't confuse with the rocket motion. Don't confuse with that. You have to always go back to the general reference location. It is up positive, left, right positive. Then SC 0, SB you just find. So that's why general equation is important to help you to secure point. Let's say you calculate the wrong value here, you substitute the wrong value here. This one you miss point, but this one will give you 1 mark here. If you don't write this one, totally you miss point for V at C, velocity at C. Huh? So this is just a life jacket for you to save you some marks. If you calculate the wrong answer previously, because you recycle the answer from the previous steps. Okay. The rest is just mathematics and only one unknown in the equation. If you press the calculator, you will get a negative velocity. You will get a negative velocity from your calculation, and you get negative 80.1 meter per second. For this module, give minimum 2 decimal place, maximum 3 decimal place as your answer. So this is just an illustration for tutorial question. So you get a negative sometime, not sometime, but in my exam paper that's set by me, I will always give you some hints in the answer. I will direct you something like calculate the velocity. Let's say this is your test question or exam question. I'll always give you hints like calculate the velocity at C and explain the direction of the velocity vector or direction of the velocity. So after you find the answer negative, you need to explain what mean by negative. Okay, VC you get negative, And then because we understand all direction going up is positive, the velocity negative, it means it go down. So you write this one negative and the direction is going downwards. Or you write 80.1 meter per second bracket downwards. Don't mix this one and this one. Don't write negative 80.1 meter per second bracket downward. Then you get the wrong answer. Observe the differences of answer. You have two kind of answer here. This one and this one. If you change the answer to positive, give the direction. If you change the negative sign to positive, give the direction. Or you can just draw arrow down, positive. Clear on how you solve question? For
Yes.
Clear? Everyone clear? Any question?
Yes, please. No, sir.
Okay, good. If no question, we continue with a new, okay, anything else we need to solve? Let me see. Okay, this is just a reminder. These are just notes. So again, why A to B, the velocity can change from 75 to 0 is because of the gravity. Some keyword here is deceleration because the gravity is negative sign. Negative sign of acceleration is deceleration. Or sometimes we will use deceleration to guide you. Sometimes we are so kind in the question, we will mention the rocket experience deceleration, or the stone or the ball experience deceleration along the motion. It means already give you hints that the acceleration is negative sign. Just put that. This also one of the keyword or one of the popular word that I like to use. Okay, this word will help you. I give you some warning sign or warning keyword in the question to say that please use negative sign for acceleration. I will use the acceleration to remind you the A value in your calculation is negative. Okay, so that's for your info. Okay, the rest is can. Next, we learn a new thing today. Before example 3 is all linear motion. Today we learn something new. We call it erratic motion. Okay, erratic motion. What I mean by erratic? There's a change of motion. When there's a change of motion in your calculation. Change of motion. When the motion change, 3 important keyword that I highlight in the blue color: your position, your velocity, your acceleration will change also. So I highlight, you cannot use a single equation to solve. You cannot use a single continuous equation to solve. So when you have an erratic motion or changing motion of particles or object, position, velocity, and acceleration will change also. Okay. So if you have an erratic motion or changing motion, ask yourself how to solve this kind of question. We can describe the motion using graph. Okay, so for today's lesson, we'll introduce you a new graph. 3 types of graph we're going to introduce. If you understand, then we can call it a day. All right. We're going to introduce you S versus T, which is a displacement versus time, the first type. Second, we introduce you velocity versus time, and we introduce you acceleration versus time graph. So when you look at the question, there's a change of motion. In your mind or subconsciously, you should know the next steps you try to answer. The question expect you to draw a graph. Okay. So, and even I will help you in a question. Please sketch ST graph, please sketch VT graph, please sketch AT graph in the question. That means if you see these three keywords here in the question, it means it fall under this section. All the equation that in this section you can use to solve ST, VT, AT graph problems. Okay, so this is a tips for you. How do you prepare for test or exam? First type of graph. Okay, there are lots of writing here, but just recognize the axis of graph. First type of graph is ST, which is S versus T, which is displacement versus T, or you can say location or position versus T. Second type, velocity versus T. Ignore all this at the moment. You will see this one later, but try to try to observe the differences of three graphs. The differences is on the axis. I think you learned this one in your SPM physics before, so we just revisit the concept. Okay, and another type is acceleration versus time. You have three type of graph for today. Three type of graph for today, and you can extract information from this one. Use that information, draw this graph. Okay, this will be the basic data that will be given. You can use this graph. Develop this graph, meaning an exam you will be given this graph or test given this graph. Expect you to, from this graph, draw this graph, and from this graph, draw this graph. Okay? I hope you can see the relationship between this graph, and this graph. By using definition of velocity, how you define velocity, how you define acceleration is linked together. So you need to call back what you learned in the previous lecture. Velocity is displacement divided by time, or you take ds over dt is a differential equation. So if you're very weak in differential, it's time to revisit your mathematics textbook. In this session, ST, VT, AT graph, you need to use differential equation and integration equation. Just give you a hint. When it comes to erratic motion, you need two mathematics skills, differentiation and integration. So if you are weak in these two topics, please revisit, polish up the skill. However, I will try to help you to recall what is differentiation, just a little bit, right? So just now we touched about velocity, acceleration. Acceleration is velocity divided by time. And again, previously we also mentioned acceleration also you can derive from displacement, where acceleration is the double differentiation of displacement. Okay, let's look at one of these graphs. First one, the most basic graph that you will see in test and exam is ST graph. So in ST graph, basically you plot displacement versus time, or location or position versus time, like this. So you always see this kind of graph, position versus time, And let's say you have a curve. From this curve, you know that your particles do not move in a straight line, meaning your S doesn't move in the linear equation of t. If your motion moves in the straight line, then you will get a straight line equation. However, if you have a just remind, if you have a straight line, then you fall under the previous section that we learned before this, the 3 Newton equation that you can use. However, when it comes to erratic motion, where you can see from the graph behavior, it's not a linear equation, it's a quadratic equation. Okay, it's a quadratic, and sometimes it's a polynomial equation. So quadratic equation like this. And let's say we start with 1 point. I mark as red colored X there. I mark as point 1. So at point 1, you can record the time at point 1, label as t sub 1. Okay, t sub 1. You can label this one as origin. At point 1, you can measure or you can record or extract from the data that here to here is your T1. Okay? And from T1, you can extend to the x-axis. Right? You'll get S sub 1. Okay, so this is a basic graph reading. Right? So to find the slope or gradient at this point, again, to find the slope or gradient of this point, mathematically, you need to use differentiation equation, which is ds over dt. To find the gradient at this point, the slope of this point, you take ds, which is here to here, the change of the displacement divided by the change of time from this point, right, to this point. But however, if you only focus on this one, you can use this equation to find differentiation equation. This actually is a slope or differentiation equation, ds over dt, to find the slope at this particular point. And usually, this S, as you can see from this line, it will give you one equation in the quadratic equation, S equal to something, something t, x power 2 or something. So it will come with S will come, this line will come in the equation. So you need to differentiate towards time, you get velocity. This is how you get gradient. Okay, at this moment, I want you to recall S versus T quadratic equation, or and then how you find differentiation at that point, where to use this relationship ds over dt, you get velocity. In other words, the first information you extract from S versus T graph is velocity. So you can extract point 1 information into velocity by using S divided by, not divide, you do the differentiation S over dt. This is not divide, it's a differentiation process. You take S differentiation towards T at this point. So I will mark as V1, velocity at here. By finding the differentiation of this point, I'll get the velocity at this point. Or you're finding the slope at this point. After that, you mark that velocity, you plot into V versus T graph. Okay. So you continue to do the same process for other point. On this blue line, you convert the information along this blue line. You can convert S T graph into V versus T graph. Okay, this is the first idea or first concept that we want to bring you. You start with S versus T graph. You use differentiation equation because of the definition of velocity. Velocity, you take S divided by T, and this equation actually is a differentiation. And differentiation give you, from the graph, it give you slope. That's why you can change S versus T graph into VT. At this moment, ignore the shape of the graph, but I want you to know that from S versus T graph, you can change to VT by using differentiation equation. Okay. Any questions so far? Any question?
No, sir.
Everything clear? Huh?
No, sir.
Okay. Next, you look at second type of graph. So let's say you already change all the dot on this line into VT graph. What information can we get from V versus T graph? Let's say you already have one graph that you get from S versus T, and now you process V versus T graph. Okay, V versus T graph. Again, let's say you have the same quadratic graph. You have the same erratic motion, V versus T, because it keeps changing the motion, V versus T, and you look at point 1. Same, repeat the same principle. Point 1, you project down, you get T1, project to this axis, you get V1. If you find the slope of this line, you take dV dt, you'll get acceleration. Okay, you take the slope at this point or gradient at this point, you'll get A equal to dV over dt. This is another differentiation equation that can help you to convert V versus T graph into A versus T graph. Okay, again, ignore the shape of the curve there. The important point is that there is a procedure to convert V versus T graph into AT by using this equation. Okay. Next, we look at A versus T graph. Okay. A versus T graph, let's say we have another quadratic equation, and I mark one point on the A versus T graph. Mark as point 1. And from point 1, I can project down. I get T sub 1. And this one is on A versus T graph. I move point 1 to the A axis. From that particular point, I get acceleration at point 1. So what information we can get from here? Just in case you have an acceleration versus T data, and can you reverse the process from AT back to L versus T back to S versus T? The answer is yes. How we do it? You know the definition of acceleration. Acceleration is a change of velocity divided by change of time, or the slope of the AT graph. Right? Not the slope, sorry. From AT graph, so you use the acceleration definition, A equal to dV dt. You rewrite the equation. You take the dt, pull to the left-hand side, you get AT equal to dV. And recall what process we do if we have dt and dV in the equation. We always add integration when we have this form, this kind of equation. When you write linearly, you have dt, dv, one side and another side. Straight away, you know that the next process is to do integration. from that process to this process. And remind yourself, in front of dv, although I do not write anything here, there's a 1 here. 1 times dv, you still get the same answer. When you integrate, although you don't see anything, there's a 1 here. There's a hidden message here. There's 1 in between this symbol. Don't write 0 here. There's no 0. If you write 0, means nothing there. There's something in this second equation here. In front the dv, there's 1 there. Means you still have velocity there. Don't, after come to this stage, you confuse yourself. You don't see anything, then you write 0. Then you get the wrong answer. There's 1 there. There's 1 inside here, hidden message. So by looking at integration, you know that when you integrate 1, here, or let's say you go back to your mathematics class, you integrate 1 dx. You integrate 1 dx, what do you get? You get x, right? So when you integrate 1 dv, you get v on that side. That side, you integrate a times the dt, you get the magnitude of the velocity. So from the graph, what does it mean? If you look at the graph, air versus t, and the curve, the blue line, and look at this equation. You learned before, right? When you learn about integration, you try to link the graph and the equation. Basically, it just means the left-hand side of the equation is the area under the blue curve. Again, I repeat. How do you link this integration equation with the graph? If you are saying integrate a dt, it means area under the curve. Okay, if you're using AT graph, AT graph with the curve, you are using integration equation. It means this one is area under the graph. This side, if you integrate, you get v, right? You get v. You integrate something with 1, you get v. I highlight the area under the graph for you to represent this part. Okay. This part is the change of velocity. You know the integration. You integrate from lower limit to upper limit, from initial or 0.1 velocity to 0.2 velocity. So when you do it, then you get a change of velocity. Okay, so this is back to the fundamental integration principle. So up to this stage, any question? Up to this stage, any question? Anything that you're not sure?
No, sir.
Yeah. Okay. So when you integrate, you get this equation. You integrate, get this equation. Delta V means you take V over here minus this V. You get delta V equal to integrate from initial time to that point, a dt. So you will get one value at that particular point. You can plot versus time. You can plot the velocity at t1 here. Same period of time, but different velocity come out. Okay. Of course, the shape will be different, right? But this is how you process from A versus T graph. You use integration. If you want to reverse back the process from AT to VT, you use integration. If you want to move here to here, you use differentiation. You move this one to this one, you use integration. Okay, it will take some time to practice, but I hope you understand what we're talking about in the class. Okay, so same, you have a t1, same time there, but the axis already changed to velocity. Okay, this is the change of velocity. Okay, it's delta V that we mentioned just now. Okay, next, we'll use this concept to reverse this graph back to displacement versus t. If you understand the concept from A versus t to Vt, you repeat the same principle by using definition of velocity. Right? We just change the formula. Then rewrite the formula, put in the integration. Same, you are seeing the graph, so area under the graph equal to change of displacement or change of position. So let me show you how you do it. If you get a V versus T graph, and let's say you have a quadratic curve, point 1, you get T1, you get V1. Of course, the far right, this curve, this blue curve, you touch y-axis there, you get V0. So just to, sometimes I do not put in there. So in the graph, this curve, right? This curve touch your v-axis, the y-axis, right? This point is V0, initial point. Why we know that this one is initial point? Because your t is 0. Okay, your t is 0 at this point. So repeat the same concept. So again, ask yourself, are you able to use a similar concept like what you learned in the previous slides to change this one into ST graph? Again, you start with definition of velocity. Velocity equal to ds over dt, or the change of the slope of that point on ST graph. But however, in this one, because we intend to change Vt into ST, so we link velocity and displacement. So that's why you use V equal ds dt, and then we pull the dt denominator to the left-hand side. And again, you know what to do when you see dt one side, ds one side. You put in the integration sign. Left-hand side, you look at the graph, link what is integration v versus t when you have vt graph. Integration actually is the area under the graph. So on the left-hand side is actually area under the graph, and I highlight for you. And this side is a change of displacement. Okay, or displacement, or change of position, become displacement. Okay, so this integration arrive at this one. So this one become delta S. This one will become this one. Start with initial to 0.1. You get your answer of ds at 0.1. So you plot the graph. Okay, on the graph you plot t1. You move up. Look at what value you get at here. You go here and then extend. You get 0.1. Okay, you get 0.1. Of course, here is the initial position. Okay. All right. It's delta S. Okay, I think we go for a short break. Then we continue to look at another two graph, which is AS, acceleration versus displacement, and velocity versus displacement graph. We cover three types of graph just now. ST, VT, AT, and then we reverse them back and forth. Summarize before we go for a short break. Let me bring you back to just now we mentioned about these three graphs. From ST to VT, you do differentiation. From VT to AT, you do differentiation. From AT back to VT, you do integration. So from VT back to ST, you do integration. Okay, go for a short break. Now it's 4:28. Okay, let me stop the recording first.